The following is the video solution from JSDT Solutions. Question 3 says, given the geometric series, and we have 3, 6, 12, and this continues to n terms, write down the general term of this series. Okay, so it is a geometric series, and the general term of a geometric series is a multiplied by r raised to the power of n minus 1. So a is your first term and r is your constant ratio. So the first term, as we can see, is 3. So that's 3. And the ratio, we'll find that by saying term 2 divided by term 3, and that should be consistent with term 3 divided by term 2. You see that when we do that, when we divide, we get 2. So it's 3 times 2 raised to the power of n minus 1, and that is our answer. Question 3.1.2 says, calculate the value of k such that the sum of this series with this general term, starting from p equals 1, ending at k, is equal to 98,301. Okay, so it's just the sum of the series. We can go ahead and expand it. So you're going to take this 3 over 2, multiply by 2 raised to the power of p, and in place of p, we'll substitute starting at 1 and then 2 and 3. So let's just get the first 3 terms of the series. So the first term is 3. Second term is 6. And it's a series, so they're really being added. And the third term is 12. Okay, and this keeps going till the kth term. Okay, so from this, you can see that it's the same series we have here. So we'll also know that r is equal to 2. Okay, so we're still trying to find the sum of series, meaning we need to say the sum of a specific amount of terms. So we need to know what goes there. To find the number of terms, we will look at the series like this. You have to take the top minus the bottom plus 1. And the reason why is because sometimes this does not start at p equals 1. So it's safe to always use that formula. Okay, so that is the formula. But in this case, you can see that p starts at 1. So whatever this ends at is your number of terms. Again, if you said k minus 1 plus 1, you would still just get k. Okay, so we know the number of terms, it's k. And now let's go ahead and formulate our equation. So we are going to use the sum of terms. So here's our formula for that. And now we're saying the sum of k terms is equal to the a value is still the same, still 3, the first term, and then multiplied by r, which is 2, raised to the power of n, which is k, and then minus 1 all over r minus 1, which is 2 minus 1. Okay, so we already know what the sum of this series gives us. It gives us 98,301. So that is 98,301 is equal to, and we'll rewrite that, but this is 2 minus 1, which is just 1. Anything over 1 stays exactly the same, so the numerator will just stay. Okay, so when we have this, you see that to get closer to k, we can just get rid of the 3 by dividing both hand sides by 3. And let's see what we get. So we get 32,767 is equal to 2 to the power of k minus 1. Okay, so we still have k, and minus 1 is just in the way. So we take it over and becomes a positive 1. So this gives us 32768 is equal to 2 to the power of k. So at this point, you see that we have a base of 2 and then k and then a number. So the equation needs to be equal. So if you can express this as a base of 2, then we can find out exactly what k is. So let's express that as a base of 2 by rewriting it first, and then on your calculator press equal to, and then shift and the fact button. And there we go. So it means that this number can also be written as 2 to the power of 15. To make this equation equal, k should just be equal to 15. And there we go. That is the value of k. Question 3.2 says, a geometric sequence and an arithmetic sequence have the same first term. Okay, so in both sequences, we can just call the first term a, like it usually is called. So let's make columns for them. This is for our geometric sequence, and that will be for our arithmetic sequence. And we know the only thing we know about them is that they both have a first term a, and we'll just call them a. And then they tell us that the common ratio of the geometric sequence is 1 over 3. So here, r equals 1 over 3. And here the common difference of the arithmetic sequence is 3. So d equals 3. Then they tell us that the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. So what that would mean is the geometric sequence has a sum to infinity. And in this arithmetic sequence, the sum of 22 terms, because they say the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity. So it is 734 more than the sum to infinity. So if that's the sum to infinity, it is 734 more than that value. And the question is to calculate the value of the first term. So find the value of a. Okay, so this is what we have been given. In these, because they both create equations, the sum to infinity is equal to something and the sum of 22 terms is equal to something. They both create two equations, but what is common in both equations would be a, and of course the value of the sum to infinity. Let's start by finding that sum to infinity. We know that the sum to infinity equals 1 over 1 minus r, and r here is 1 over 3. So the sum to infinity so long is a over 2 over 3. Okay, and if you divide that, we're saying a divided by 2 over 3. You can use the method of tip and times. So you would tip this, meaning swap the numerator and denominator, and change the division to a multiplication. So that means that the sum to infinity is equal to, numerators multiply, that's 3 over 2a. We can just call it that. Okay, so we know what the sum to infinity is here, 3 over 2a, and we know that a here is a here as well. Okay, so here we have the sum of 22 terms. So we need the sum of series formula. So that is Sn, which is 22, is equal to n over 2, but we know n is 22, so over 2. And then 2a, which is what is missing, but is common in both, so we'll still call it a, plus n minus 1, which is 22 minus 1, multiplied by our difference of 3. Okay, and then we close that. And now we are saying that the sum of 22 terms is equal to the sum to infinity and then plus 734. That is what the sum of 22 terms is. And then we'll just simplify this. So 22 divided by 2 is 11. And then here, that's just 2a. And we can now simplify. That will be 21 times 3, which gives us 63. So that's plus 63. And then let's distribute that 11 because we can't divide. So that is the sum to infinity. And we have plus 734 is equal to, and if we distribute here, we get 22a, and we could just write a in color so that we know it's the same thing there, plus 63 times 11 is going to be, we have 630 plus another 63. So this is what we have. And you see how the sum to infinity is the subject here. We might as well make the sum to infinity the subject. So take 734 over, meaning the sum to infinity is equal to, and we have 22a, and what is 693 minus that? Just say 734 minus 693, and you know this will be negative. So that will be negative 41. So minus 41. And now we have the sum to infinity and the sum to infinity, which represent the same thing. So we're going to equate them. Sum to infinity is equal to the sum to infinity. So 3 over 2a is equal to 22a minus 41. And then we can just solve for a. So this is 22a minus 32 is equal to, and we can take that over. That's going to be positive 41. Okay. And now we can subtract. So 22a minus, this has a denominator of 2. So you can make a denominator of 2 by multiplying top and bottom by 2. So that's 44 over 2. If you say 44 minus 3, you get 41. So that's 41 over 2a is equal to 41. Okay, to solve for a, you can simply multiply both hand sides by the reciprocal of this number, which will be 2 over 41. That way, the numerator cancels and the denominator cancels. And we will do this on both hand sides. So this is going to be, remember, this is really in the numerator, that's in the denominator, so they'll cancel. So that gives you a 2 there, and these cancel completely, and that gives you an a, meaning a is finally just equal to 2. And that is our answer. That is the value of a.